Welcome everyone. Today we have our another new episode and we will discuss about drone technology. We have our world famous speakers, Professor David Smith, as well as we have our another genius and he is talented from robots everywhere. Hello everyone, how are you? So I want to start these discussions, the drone technology. I want to start from Professor David Smith.
Oh, Sharif, thank you. This is a very interesting technology discussion because most people think drones are pretty recent occurrences, but some of the early days of drones were actually back in the 1920s uh, with a drone called Fairy Queen, and in the 30s, the de Havilland Queen Bee were some of the early drones that were really unmanned airplanes that were being used in different situations. The first one that's kind of interesting is many days the early drones were not used for surveillance and things like we're doing today, but they were used as targets. And they were targets so that other people, battleships, and people on the ground can test firing at aircraft in the air. Um, and it's kind of interesting going forward. There actually was regulation that was put in place by Canada in 2019 on what they called remotely piloted aircraft systems. And that really got us into the use of drones and the regulations for drones, which have continued to progress since the uh, early days of the last century. Today, the word drone is, for most people beginning to look at aerial drones, but a drone could be an underwater drone. There's many of those, and I can go to Best Buy and Amazon and buy an underwater drone as well as an aircraft type of drone. But there's also drones which are surface drones. We've seen in the Middle East recently a fairly widespread use of uh, marine drones to do tasks all up and down where there's mines and other things in that region. We've also seen uh, the increased use of autonomous land vehicles. You know, they are the early precursors to what we're seeing in the autonomous manned vehicles, where I can sit there and have my Tesla take me somewhere with being hands off on the steering wheel. But that is kind of where drones have come through over the last century plus to get to us to where we are today. And drones have just so many different uses that you can begin to use. And kind of in the air drones, there's these multiple classifications there. You can have something that's called a handheld drone that I can take with my hand and launch it. And it really has a range of up to about 1,500, 2,000 feet in altitude in about 2 kilometer range. But then you begin to go through different ones to tactical, where the altitude goes up, the range gets higher. You have some which are hypersonic now and can go up to suborbital range. You've got some drones that can actually go up into space. One of the newest drones that is being worked on right now is called the CIS Lunar Earth Moon Transfer Drone. And that one to me is particularly interesting because it is beginning to project that we will, in essence, have a drone based transport system for supplying manned outposts on the moon. And that's the precursor for going out further into our universe to do that type of exploration. So there's many classes of drones, many different types, and their applications are very broad. You see them early in the military, but you see them in forestry and agriculture and um, photography. I mean, every place in variable now. There's actually a lot of supportive technology being put in place. There's a new type of GPS and tracking system being used, which is actually targeting drones to where it can not only has XY axis says XYZ and it has delta T on it. And this is being used. So, for example, I'm in a high rise apartment complex and I want to use a drone to deliver pizza to me on the 22nd floor. How can I begin to do that? Can I fly through and put it on a balcony? What can I do with things like that? So even the supportive technologies, the optics, the hyperspectral, the multispectral, the LIDAR, and other things like that are being advanced to where it's making drones today very capable, whether they're air-based drones, land-based drones, or water-based drones. They're all moving very rapidly today. So, Sharif, I hope that's a great first intro.
Mhm, mhm. Excellent, excellent, Professor David Smith. Uh, Matthew, you are from Robot Everywhere. I know you are an engineer. So, what you want to share with our audience?
Well, what I wanted to discuss is that drones are not just things that fly. You know, most people think of a drone of a quadcopter. As Dr. Smith said, there are many other types of flying drones. There are also underwater unmanned vehicles. There are ground unmanned vehicles. This is a little inspection robot that we built. We're showing how it can navigate grass despite being smaller than the grass. And this here, by definition, is a drone. This is an autonomous mobile robot that whose main intention is observation and surveillance. This is a drone. This is something we don't sell this, but we give it out for free. You can just download the plans from our website, and you can just build yourself one. You can send it down a pipe. This uses an old cell phone as its camera. The idea was to recycle old cell phones. My point here being that this technology not only is at this point fairly ubiquitous, it's not something that only an army or big corporations have access to. You can just get yourself one. You can get yourself a toy from Amazon for $30. You can change the firmware on it. You can put autopilot on it. You can put the Navcom AI with the parallax propeller on it. You can put a number of things on it. And what that will do for you is you can have your own drone setup. You can do your own surveillance. You can do your own industrial inspection. You can even use the things to deploy. This is a little quadcopter. This is a $30 quadcopter deploying a cell phone repeater to be used in an emergency. There is no need to depend on a military for this. There is no need to depend on the cloud for this. There is no need to depend on a company for this. You, person listening, can, with a very small investment, less than a new cell phone, start your drone program. And I encourage you to do so, because this sort of thing must happen from the bottom up. That's what I've got. I'm going to be showing some videos of some of the stuff we have built. Again, this guy is a flyer. It's it's a modified $30 toy that has been set up to use its camera actuator to fire a flexional wire to deploy this little thing here, which is a cell phone repeater. The idea is to use them in emergencies. Let's say that there has been an earthquake. All the cell phone power lines are down. Cell phones are down. This guy here has a solar panel. It can fly itself to a roof. You can see here. You can actually see it messing up the landing a couple of times. I kept it because I thought it was funny. It can deploy itself on a roof. It can deploy its own antenna. There it is. It just fell over. And it can restore communication after a disaster. And this is not something that you need to wait for the United Nations or the U.S. Air Force or your government to do. This is something that you can do yourself with a couple $100. Mm-hmm. This stuff is not the future. This stuff is here, right now, available. Mm-hmm. That's basically what I've got. So you can kind of see that it did deploy the antenna. Anyway.
Okay, thank you. Professor David Smith, if you want to give any feedback on this technology, especially he's a tech entrepreneur and taking a lot of initiative. I think he has more innovation, right? Matthew, you have different kind of innovation. Previously, you joined.
Yes, and I am. Yes, and frankly, 95% of what we do, we just give out for free.
Okay, okay, that's good. That's good. Professor David Smith. Yes.
What you saw with him is very interesting because he's using something called commercial off-the-shelf technology or COTS technology to do things that a decade ago would have been impossible to do as you look at how the whole area around drones have taken. The ability to take a smartphone, use it to control much of the operation of unmanned, in this instance, aero vehicle. You can do the same thing with water and others to get there is something that's going to be enabling. And drones is a very interesting technology because, with the exception of the very large drones that are primarily the use of the military or organizations like NASA uh, in the United States and others, most of the drone technology, whether it's a land based drone, a water based drone, or an air based drone, is well within the range of all the developing nations. And it can be game changers as you look across the different areas of the developing nations. Some of the very interesting applications of it that can be used and really customized by region and things like that is in the area of, for example, of agriculture. Uh, Drones are being used a lot by things from managing crops and livestock to to even looking at things of spraying uh, uh, crops and things and for insect control. Drones are also being used a lot today, and I can see this particularly in developing nations for conservation. They are looking at and mapping the changes in the ecosystems around them and what they're doing, and they're monitoring uh, compliance with regulatory events and things like that. Now, as he spoke, they're doing a lot in disaster mitigation, but also in relief. They can go places that's difficult to do, particularly with roads out and power out. And in many instances, particularly in the rural environments today in the United States and particularly in developing nations, they're being used as a way to deliver medicine and other necessities to places that are difficult to get to. They're being used in logistics. They're being used in law enforcement and first responders and fighting fires. There's many instances where drone technology is used to be able to, with a fire department, deliver chemicals and water to higher levels in buildings or go inside of a land-based drone, go inside of a building and deliver it there. Uh, I mean, it's just many, many different places that you can begin to see drones being used. Now, what are some of the emerging things there? Many of these drones need to be customized for each of the regions with what you're doing. A drone that might be used in New York City or in Los Angeles or in Tokyo might not work in the rural environment because of how the very differences are. The instruments that can be used on them are very diverse too and need to be customized and adapted to what it is you're doing locally. The new General Atomics second generation Raptor is a very interesting drone. It is a big drone, but it has places for 12 different instrument pods to attach to it, in addition to its base sensor platform, which includes LIDAR, radar, hyperspectral, multispectral, optical as well. And it's a drone that can take off and land without autonomously by itself. It can fly autonomously even in areas with other traffic there. So many of these of the higher end drones are getting away from having to have an operator control it all the time. And this is both in air drones and in underwater drones in particular. This type of autonomous operation is becoming more common. Now, the sensor integration for those, the payloads, the ability to program and develop science for them to do more remote tasks is an opportunity, particularly in universities and developing nations, because the challenges there are different. Uh, Going through and working in a marketplace like what I would see in downtown Bangkok is again one that has to be produced and ranged for that. And the local entrepreneurs are going to have an advantage using the commercial off the shelf drone technology to begin to put solutions in that place. So that to me is one of the examples, Sri, of where this technology can have a lot of application from both the serving the needs for entrepreneur activities and for research in your colleges and universities there.
Speaking of COTS, one of the things you can do, if you look at your regular smartphone, it is a treasure trove of sensors. It has two cameras, an accelerometer, a GPS, a compass. Most of them have Bluetooth so that they can also do sensor aggregation for other things that you can connect to it. We have a method to attach standard I2C sensors to the audio port of a cell phone that we also give out for free. So you can construct yourself. This is something that we built when the pandemic was starting. This is being used to deliver groceries in our subdivision here because we got a lot of old people and they did not want to be exposed even with social distancing. We actually built this in 2019, so that was somewhat prescient of us. My point here being, at this point, you can use COTS to do quite a number of things. Machine vision used to be something that you needed a DoD grant to work on. Now you can buy a machine vision platform for less than $100 and teach it, and you can run TensorFlow on it without having to use a cloud, and you can teach it to tell apart shapes. That's how that little unmanned tractor that took out weeds in the video before worked. Again, this technology is mature. It is conceivable for a farmer to just buy one of the damn things and just deploy it. And beyond that, what needs to be addressed is the ability for people to do their own maintenance, do their own repairs. Because one of the big dangers at this point is vendor lock-in. Fortunately, there are many open source solutions, but you can see it now with the autonomous tractors that John Deere is deploying. I'm sure you followed all the drama with John Deere and the fact that they don't allow people to repair their tractors that they buy. And people have been having to come up with software hacks for their own tractors. By the way, most of the new tractors, you don't have to steer them anymore. Normally, there's a person in it, but they steer themselves. They have GPS on a mast on the tractor. They have differential GPS emitters at the corners of the field, and they use that to do the actual tilling. At the same time, the problem is that if you buy one of those, you're locked into them. You have to use them to repair it. You have to use them to do maintenance, do upgrades. This is no longer a technical problem. This is a sociological problem. We have to decide if we want to go into the direction of having, 3, 4, 5 vendors that control the technology, or if we want to go towards a more bottom-up model, an open source model where you can build your own thing. You can go to your local engineering firm, which might be us, might be, Dr. Smith, you guys, and say, hey, I'm a farmer. I am growing garlic in this greenhouse. I want a machine that eliminates any extraneous plants. And the person you went to can say, okay, yeah, they need this component, this component, this component. They put them together. They put together the firmware quickly. You don't even need to code stuff anymore. You can just do it visually at this point. Use Blockly, for example. Blockly is a visual programming language. You don't have to type anymore. You just put together, again, blocks of code like you would Lego bricks, and that can do 80% of your job. And, the person can then leave and go home and have their quadcopter or their little tank that shoots out a little laser beam and destroys the weeds that are in your garlic greenhouse. This is not the future. This is the present. We have to decide as a civilization if we want to do this top-down or bottom-up. Top-down may be slightly more efficient, but bottom-up is immensely more resilient. And yes, this is a drone. This is one of our this is one of our ant bots on a bigger chassis delivering a smaller ant bot to a UPS office for shipping.
Mhm.
The total cost of what you see in this video, being the carrier drone and the little robot that was being shipped, is approximately $120. And again, you don't have to buy it from us. You can just go on our website, download the schematics, print it yourself. We're good. Just don't sell it on eBay.
Mhm. Yes. That's great. That's great, actually. Professor David Smith, actually, if you share for our audience few other applications for the drone, especially in agriculture, uh, even different places we can utilize this drone. Even in Malaysia, there is some good corporation, those who are doing very well. So, beside that, if you share few other applications for our audience.
I'll be more than happy to do that. Uh, drone technology really got its place in defense in the military, and of course, there's applications in there. Many of the drones in that space are for surveillance, but there's even some for offensive operations and others. Uh, One of the places I see a lot of promise, particularly in places like Malaysia and others, is, as I said before, kind of in the emergency response area. You know, uh, we've seen here that small drones outfitted with thermal imaging cameras have been really useful in identifying people who go lost of after disasters, trying to find where people are. There is also a wide area of uh, emergency response that can be used in areas like I talked about earlier, firefighting and in delivering materials there. There's one that, excuse me, is really interesting experiment where one of the actually Asian universities has featured and tested an ambulance drone that can deliver defibrillators wherever there is a need for that in communities where there are not defibrillators in the area. So it's a very good way to begin to take and rapidly move first response, emergency response things. We talked earlier about how it can be used in humanitarian and disaster relief. Uh, Here, back in 2017, when uh, Hurricane Harvey hit the Gulf Coast here in Texas, where I live, drones were used extensively, both by the government, but also by commercial companies. Um, my houses are insured by one of the big insurance groups here that actually flew drones over the flooded houses in the Houston area and in the coastal Bend area there, and actually gave their policyholders a look at the houses that were underwater before the government even got there and did that. And they were actually issuing checks based on what they saw in the drones to people whose houses were destroyed. We talked about conservation. Disease control, particularly in the agriculture area, is another really interesting one. Over in UK in the London School, they're using it throughout the Philippines to track movements of different insects and things to try to combat malaria there. And that is a very interesting one. You're seeing it used drones used a lot trying to help control diseases throughout the whole world. Uh, Another tropical one is looking at things with the spread of parasitic worms. And Microsoft and University of Washington and Stanford are doing a lot of that, trying to use drone technology to do it. We spoke about healthcare and a lot of places with healthcare. And medicine delivery in the rural areas, particularly in Africa, is another area like that. We talked about agriculture earlier, but one of the differences in agriculture from 50 years ago to today is the use of data. And drones combined with Internet of Things sensors are really revolutionizing what you can do in agriculture, the yield you can get from a hectare of land and see it. Weather forecasting, another big use of drones. In addition to the aerial drones there, this is where you see both unmanned surface vehicles used in water for that, as well as undersea with that. Uh, Drones are going to be very active as we begin to look at how autonomous maritime operations work. We already know that there's autonomous ships, just like there are autonomous trucks that are being used as delivery vehicles. That's going to increase. One of the things is a couple of the companies like Rolls Royce, they're building autonomous ships, but they're putting drones on them where they can use the drones to inspect ships and to go out further into sea. And you're seeing drones used throughout that. You're seeing drones in waste management, energy. Uh, Energy is kind of interesting. It used to be that where you had high energy transmission lines, you would either put people in trucks or in helicopters to go and inspect them. They're being used, drones are being used there for that, both over land and offshore. And they can use some specialized thermal sensors and high resolution cameras that can actually do that type of inspection better than humans can. You're seeing it in mining, in construction planning. I love to see it in construction planning. But one of the other areas I think, particularly in Malaysia, that you're going to see a lot of application is in land management and construction planning, and the ability to survey, put the pieces together. But also, you're going to see the bigger drones begin to actually move materials around the construction project. Uh, there was a thing by the University of Switzerland where they developed drones to move polymer bricks, and they were able to use drones to move these bricks to actually build structures out of it using drone technology. Uh, all many different places you're seeing it, but we're beginning to see drones used in personal transportation. We're seeing drones used in many others. Airbus is kind of interesting. Airbus has pioneered a small drone that they manufacture to go and inspect their aircraft before they go. And they have actually Airbus has launched a subsidiary called Airbus Aerial, which is really focused on using drones to do surveys, to look at aircraft, to look at vehicles, to go and inspect the buildings you have, the high rise buildings and things, to see if there's damages, to see if there's precursors that could predict a failure, to be used in maintenance operations. So, Sharif, you can see that the application of this type of drone technology, be it aerial, land, or water drone, is really as much as you can imagine it being used, it probably can be used today because our sensors and our communication protocols have gotten so good that, as we've talked before, today almost every device is an intelligent connected device, and drone technology is well set to take advantage of that.
Thank you, Professor David Smith. Mr. Matthew, uh, as you are developing different kind of drones, so beside your technology, uh, if you share few others solution which will be helpful for this industry.
Now, there's something that I'd like to go back that goes back a few thousand years. Unmanned technology in general also makes something economical again that hasn't been for the last 2 centuries or so. And that's sailboats. Now, this video here is ancient. This is from 2007. This is an autonomous sailboat. Now, why did sailboats go away? Sailboats went away as a mode of transport because they're slow. So they're slow. You have to, feed the crew. You have to look after the crew for months at a time instead of weeks at a time to cross an ocean. But if there's no crew and you're transporting goods that don't go bad, like let's say you're transporting iron or oil, even now that we have the ability to predict demand months in advance, which we do, it's perfectly fine to have slower ships at sea. And guess what sailboats don't do? They don't consume fuel. You can have an autonomous cargo sailboat just cover the deck in solar panels for the auxiliary power needs and the servos. You put some masts on it. You can transport non-perishable goods, again, like iron, or I don't know, for example, feedstock for paper mills, stuff that doesn't require getting there quickly as long as it gets there reliably. For 1% of the cost in fuel that you do with a modern container ship. And these things can be containerized. The point being is that there's nobody on board. You don't have to worry about insurance. You don't have to worry about provisions. You don't have to worry about delays. You don't have to worry about people getting hurt or sick. So you can afford to stay at sea for longer. And I believe that unmanned technology can bring back, for some types of goods, using sailboats for commercial traffic. Imagine the environmental impact of this. I don't know if you've ever seen a container ship being loaded. I don't know if you've ever seen a container ship being refueled. It eats up as much juice as thousands of trucks. And it's immensely less efficient than a train or even a truck. Unmanned technology can give us back the benefits of a sailing ship while significantly calming down the drawbacks. This is a different video. This is just a laser that we use to detect chlorophyll. Speaking of which, going back to what Dr. Smith was talking about in agriculture, a modern chlorophyll sensor can be built out of a cell phone camera and a few gel lights. You can put one of those on a quadcopter and literally get a picture of how healthy the plants in your field are. You can look at the black spots. If you use the right filter, you're going to see a sea of purple, and that's your chlorophyll. You can look at the black spots to see where the plant is not doing well, is not in good shape. And that's something else that, again, used to take a lot of space, but that you can now chuck onto a quadcopter. Again, this technology is not in the future. This technology is here.
Mhm,
That's what I got.
mhm, mhm. Professor David Smith, like example, yesterday we discussed one point about innovation lab, and definitely USA has many good innovation lab, many good mentors like you. Yes, even Asia Pacific, some point they are also trying to develop different innovation lab and other things, especially for developing this kind of innovative technology, which will be the futures, as well as it will be part of Industry 4.0. So, what type of strategy, especially developing nations, can take to develop this kind of robots and drone technologies and this kind of things, and how you want to guide the youth community?
Uh, Great question. If I'm beginning to look at drone technology, the first level is to look at the different vehicles themselves. But where the differences can come in that can have big impact is on the software that's actually controlling the drones, with the software that's interacting with the sensors, and you're taking the information that the sensor is picking up, turn it into data, and then into information, knowledge, wisdom, and action. Uh, Drone technologies is pretty good about beginning to look at what's around it, sense what's around it, being able to detect it. But then you have to have the software systems and things to be able to turn that into intelligence and be able to act on it. One of the other areas that particularly universities need to work today is what are the privacy concerns? What are the ethical concerns? What are the regulatory concerns around the use of drone technology? A whole large industry has grown up with anti-drone technology and with drone detection and tracking methods. You know, some of the places that you're seeing anti-drone technology deployed is to protect areas such as airports, critical infrastructure, uh, military bases, hospitals, and large public spaces such as stadiums. You know, an individual with a small drone can wreak havoc in those, cause airplanes to crash, to deliver bad materials into a soccer stadium or a football stadium would be disastrous. So this whole industry around that, and that's an area where it's still very early in its infancy of being developed. And so there's much work that needs to be done to advance that and go forward. Uh, the other place that I think that you're going to see a lot of opportunities for science and academia work there is how do I integrate drones together? Right now, most of the drones are outside of the military are working in a standalone mode. How can I use a flock of drones, each with different sensors, different things, to deliver a wide area intelligence to have them do. We saw at the Tokyo Olympics that drones were being used as part of an aerial show for an entertainment purpose. But you saw clusters there that were beginning to be able to control and program to do things. That is an area where there's a lot of research and opportunity for that. So from an entrepreneur standpoint, particularly in one where a lot of the technology is commercial, off the shelf technology that can be taken and enhanced and used in ways that were never imagined when the base hardware and the base software was written. So, Sharif, I hope that answers your question.
Mhm. Yes, sure. Uh,
Smith, I have to
Matthew,
contradict you. I have to
yes.
contradict you. You're wrong. You're wrong because this stuff is not something that universities need to develop. This stuff already exists. I propose here for an example. This is an anti-drone tank from 2014, equipped with a laser intended to destroy drone cameras.
Hmm.
This is from 7 years ago. This exists. As far as drone swarms, we have deployed. We haven't really done much with swarm technology ourselves. I know other companies have. You can look up Daniel Campbell, for example, with Drop Drone. He's done some of that. And this was again a few years ago. We have deployed drones in groups of up to 6 to do deliveries in a sort of a relay fashion. One drone does part of that's part of the itinerary. It hands off the package to another drone, and so on and so forth. This exists. This has been done. I've shown that in a couple of videos. You actually saw our group drone software in the first video that I showed. So I agree with you that this stuff is important. I agree with you that this stuff needs to be deployed more widely. I disagree with you in the fact that it needs to be developed, it needs to be improved, but it already exists. On top of that, you can just go on, Ardu Pilot Forum. You can go on the Parallax Propeller Forum. You can download the firmware for it yourself. You can build yourself a drone swarm for less than $1,000 today.
Okay, that's good. That's really good. Yes. So, Professor David Smith, I have a question because uh, what we know that this kind of technology will be expensive for the developing nations. And what do you think? The price of this kind of technology will decrease, or how it will work for next 5 years?
The cost of the consumer quality, the low end commercial quality drones are going to continue to decrease. I mean, as he has said, I can get plans from many places and build my own low-end drones today, particularly the aerial drones and land-based drones, pretty easily. I can go into a consumer store like Best Buy here, and I can buy both aerial drones and water drones off the shelf there. Then I can use, and the price for those are falling. Now, the price of the larger high-end drones is increasing. The Some of the new military surveillance drones cost a couple of $1 billion to build and equip it with its sensors and everything, and for the ranges. So that high-end market is still growing too, as we're seeing more and more places doing this. There was an article I was scanning this morning about how Australia has now gone to the next current generation of drone because they are an island nation and they have to use drones so much to surveil that, and that the central part of Australia is still very wilderness. So they have become a high-end test bed of the commercial drones and the military drones to work there. But we are at the point where do-it-yourself individuals can effectively build functional drones. Uh, I am a judge at state levels for some of the autonomous robots that are being built in middle schools and high schools in the United States. And the ability to take in, that is basically a drone as well, to build them by themselves in middle school, in sixth, seventh grade, program them, use object recognition, use Tesla programming to go and have them do autonomous complex tasks, is at the point where kids in early in their school life can go and build them and develop them and deploy themselves. uh, Makes it where the cost is just going to continue to decline, and is one where almost any company, school can afford to go and acquire them to be used in a lot of different areas like that. I mean, the fact that now you almost don't see a real estate photographer or a wedding photographer without a camera drone kind of is a testament to the falling prices, but the dependability and reliability of them as well, and their ability to carry uh, sensors, cameras, and others, and the radio links coming back so that you can get the high quality video, the high quality imaging back to you in real time. Because the real time nature of drones is one of their huge advantages in the different tasks you're doing. And yes, I mean, the first drone swarm was back in 2014, that was in the commercial sector and can be used. But what was to me interesting is some of the drone swarms for the entertainment are coordinating autonomously 1,000 drones, 1,500 drones is part of it, and having them all fly in close formation is tremendous computational, tremendous sensory technology that is just going to get better as the algorithms and the neural networks are enhanced around them to make it where they can react more in real time. So to me, that is some of the interesting science that still needs to be done on this.
Thank you, Matthew.
Yes.
Yes, I think you want to share more new technology with our audience.
No, it's just that I could like a chance to also answer the question of what I see happening in the next 5 years. My concern is that there are two ways we can go here. We can go the centralized way or the decentralized way. My fear, the bad future for me, is one in which drone technology can only be deployed by state actors or large corporate actors, and they will use regulation to essentially turn back the clock here to where you as an individual cannot own your robotic retinue. The good future is one in which this will remain a possibility, Personal robotics will continue to advance. Open source robotics will become the standard, as it has happened in many ways for cell phones. Android is open source, and the 80% of cell phones out there are Android at this point. I want to see a similar situation for autonomous robots. I want a situation where you can go buy parts or you can go buy a toy. You can go home, you can take the remote control of the toy out, you can put in an Arduino controller or a Parallax propeller controller, load it with your own firmware, and have it do your bidding rather than depending on an institution. We have a choice for this technology. We can go top down or bottom up. And again, bottom up to me is superior because it gives you better resilience. Monocultures are dangerous. If you have a monoculture, be it an agricultural monoculture or a technology monoculture, the moment somebody figures out how to mess with it, the moment that there is a virus, either of the biological or software variety, the moment that there is any kind of subversion attempt, your monoculture self will be destroyed. Whereas in fact, instead, if you have thousands of options, you have open source, everybody can do their own implementation, it is much more resilient against disasters. It is much more resilient against malicious actors, wherever they might come from. This is a new technology. Drone technology right now is where computer technology was, let's say, in 1990. And we dodged a bullet in the 90s. We could have had, a world in which every computer has a Microsoft operating system. We could have had a world in which uploading code on the internet is restricted, and we didn't get that, and we are all better off for it. Robots must exist to serve people. They must exist to serve the individual. If they are remain the purview, or worse still, are made to become the purview of only nation states or corporations, we have a problem, because that effectively changes the balance of power away from the individual human being. Isaac Asimov wrote the Three Laws of Robotics. I'm not going to quote them here because I think everybody knows them at this point. They are about the individual. A robot must not harm the individual. A robot must obey the individual. We have a choice to make between top down and bottom up. Please, as a species, let's choose bottom up for the sake of redundancy, for the sake of reliability, for the sake of resilience, and frankly, for the sake of human autonomy.
Oh, that's very interesting. Professor David Smith, I think if you want to give some sort of feedback, because my friend actually bringing different technology as well as some other innovations which will be helpful for the drone industries. And one thing I have in mind, like, can we predict what will be the real market values of this drone technology, like for next few years or upcoming 10 years? What will be the values of this market?
Uh, Deloitte has done a recent forecast where they believe that drone technology, and this is all the different flavors of drone, will be a $100 billion marketplace by 2027. So, going out 5 years from now, $100 billion is not a bad market to look at things that have such a wide range of usage and such a wide range of costs that can be used there. Um, if I throw in the very high end drones, such as the ones being envisioned to be used in space, such as some of the very high end military drones that are capable of being offensive as well as surveillance. Uh, that $100 billion probably comes more like $250 billion over the next 7 years. If you begin to look at those development life cycles. Uh, And what the other thing we're seeing in drones is the increasing utilization of what's called a lights out, hands off drone. And that is where there's not a human in the loop. Much of the drone technology today, you need a human in the loop to control it, to help direct it. Uh, but it's begin to be used that way. Um, and you're going to see those changes come out. So it's a very large marketplace as we begin to develop specialized applications in each of the areas, like the first responder, the emergency response area. You're going to see those numbers increase. You know, there was piloting in UK of a drone-based ambulance system where you actually flew it out there to the location and loaded a patient in a container in it and used the drone to fly it back to meet either first responders coming out there mobile or back to a hospital. And you add applications like that, and that market cap for using them is going to do nothing but expand uh, and grow. So it's a large marketplace, but one with such a diversity of applications and industries that there's still a lot of opportunity for innovation and entrepreneurship in it. And we're seeing so many early uses of technology, particularly at the lower end, that there's a lot of opportunities to make money and provide services.
Mhm. Thank you. Uh, Mr. Matthew.
Yes.
Yes. Uh, so this is very interesting discussion, and definitely I know that uh, you are a very good innovators and you have a lot of technology. So definitely in any point, World Talent Economy Forum can support your initiative. We are open for that. So I request all of our audience that this session is very important, especially you have to understand about drone, especially in terms of uh, analyzing the factor. I think Professor David Smith do a excellent job. On the other hand, Matthew actually give a real life example, which will be helpful for our audience and as well as for the industry. I think academy also can learn many things from today's episode. This will be very helpful for our youth community, those who want to learn how the developed nations can take different kind of initiative. They develop their startup and they grow their business. Thank you everyone for joining today's session. I directly want to go for concluding remarks. I want to start from Matthew.
I would like to agree with Dr. Smith. Again, my assessment is that drone technology is now where computer technology was in roughly 1990. You know, you had the geeky kid in class having a computer and messing with it. And, 10 years later, everybody had a desktop computer. And 20 years later, everybody has a smartphone connected to the internet. And this pace of change is accelerating. Drones, robots are here to stay. They're not going to look like the robot made from the Jetsons, but they are going to be a part of our life, and you will eventually stop noticing them because they're so numerous. So what you have to do is make sure that they remain under the individual's control, because this is happening. This is not something that we can turn the clock back on, and we shouldn't. What we should do is choose to prioritize a situation where the robot serves the individual. We want to make very sure of that, because otherwise, eventually, it's going to be the other way around.
Thank you. Professor David Smith, what's your concluding remarks today?
Drones are one arm, one piece of a connected system. And I actually love the name of his company, Robots Everywhere, because what that tells to me is it's sensing, it's computing technology, it's communicating technology that are all put together to serve a practical need, to solve a problem, to do services, to put the elements together. To me, as I look at drones, and again, the wide definition of drones, not just the aerial drones. Uh, their real purpose, as we talked about the applications, is to achieve a result, to deliver a service, to deliver capabilities, uh, from entertainment to healthcare. And those type of capabilities is where entrepreneurships typically have excelled, is bringing unique solutions that meet a local need or a global need. And I see that's where drone technology still has a lot of applications. I can see particularly drone technology beginning to be used in water-based application very easily. Uh, and applied. I remember having to get on the radio and respond to people who ran out of gas. I could use a drone to deliver gas to a ship that's in a lake or offshore, a recreational one. So again, many, many, many different applications. And it's just that's up to our imagination of how to apply this fusion of technologies together in a way to meet those needs and provide those services. And again, a lot of opportunities and opportunities where no matter where I live in the world, there's going to be needs where drones can be applied, from every different place. We're seeing drones used in home security now, and other things are seeing them used for mobility. A lot of applications. So it's really up to the entrepreneur to do it. But I agree with the other thing. The regulatory side, the privacy side are still going. There's here, the state I live in, Texas, there's stories every few weeks of homeowners who get fed up with drones flying above their pool, of taking the drones out with shotguns and actually shooting them out of the air. So there's that side as well. So again, it's all these elements coming together to create a thing that serves humankind in a way that makes sense. So, Sharif, great opportunities in this area, and thank you for letting me be part of this.
Thank you, Professor. Thank you, Professor David Smith, and thank you, Mr. Matthew, for joining today's session. I'm sure this is really great example of open dialogue and great example of scientific discussion. In fact, because our audience especially get some good experience how actually a lab actually developing different kind of technology. On the other hand, Professor David Smith is an expert and he's a CTO for one of the famous company, and I'm sure it will be very helpful for our audience. I request all of our audience, please share our content with your government, with your academia, with your corporations. And if you have any specific questions regarding this drone and drone related technology, beside that, if you want to learn more that how we can innovate this kind of technology, we are taking initiative, we are developing our innovative lab. And definitely the speaker, those who join regularly in World Talent Economy Forum, they will join and they will teach you remotely. So this way we can develop a better ecosystem. And beside that, any kind of I know many of our audience need many solutions. I'm sure our speakers, our board of advisor, our scientific committee members, everyone ready to support the local communities. So thank you, Professor David Smith, as well as my friend Mr. Matthew, for joining today's session. This is an excellent discussions, and definitely it will be very helpful for the developing nations, and it will be helpful for their futurist thinkings and this kind of thing. Thank you, everyone. Thank you, everyone, for joining today's session. Bye bye and take care.
Thank
Thank
you.
you.
Thank you.